In this lesson, we're going to go over solving linear inequalities. Our objectives are to understand linear inequalities, then we're going to learn to solve them, and then we'll graph the solution to linear inequalities and write the solution set using interval notation. So just as a quick review, an inequality compares two values. So we have our inequalities of greater than, less than, greater than or equal to, or less than or equal to. So when we go to solve an inequality, it is very, very similar to solving linear equations. There's a couple of things that we need to keep in mind. Multiplication or division by a negative number when you're solving means that you must change or flip the inequality sign. The other piece that we need to remember is that the solution is usually a set of numbers rather than just a number. So when we solve equations, for instance, we might get something like x equals 3. But when we solve inequalities, we'll most likely get x greater than 3 or greater than or equal to, whatever the starting symbol was or whatever happens to it as we're solving, but it's usually more than one number rather than just a single number, like solving an equation. Okay, so the first example, solve and graph the solution set, and then we'll also write the solution set in interval notation. So again, we're going to start off solving this just like we would a linear equation, where our goal is to isolate or find x, and in this case, we're going to find the set of solutions rather than just one single number. So we'll start by adding 23 to both sides. So we have 6x less than 24. Okay, and then to get x by itself, we'll divide by 6. So on the left-hand side, this is x less than 24 divided by 6 is 4. So in this case, our solution set are all numbers that are less than 4. We'll graph this on the number line. Okay, so again, 4 is the endpoint. There's no or equal to, so it gets an open circle, and we're talking about all values that are smaller than 4. So this would go to the left. Okay, and then we're asked to write our answer in interval notation. Always go left to right. So the leftmost endpoint is negative infinity, and the rightmost is 4 with an open parenthesis. You can also kind of check your solution set as well. You can pick any number less than 4 and see if it'll make the inequality true. So I'm going to go over here. I'm going to check 0. Okay, so what that means is I'm going to plug 0 in for x. Oops. Okay, so we'll keep simplifying. So 6 times 0 is 0. Negative 23 is less than 1. Okay, so that's what we're looking at when we say a solution set. So you can plug in any number less than 4 and your inequality will be true. Next example, solve and graph the solution set. We'll also write the solution set in interval notation. So we'll begin by solving. We'll get our x's to one side and our numbers to the other. Okay, so I'm going to subtract 5x to get negative 4x plus 9 is less than negative 7. Now I'm going to move the 9 over. And we're going to go up here. So we have negative 4x. Our inequality symbol stays the same. Just because we subtracted 9 from both sides, it doesn't change it. It only changes when we multiply or divide by a negative number. So it stays as a less than. Negative 7 minus 9 is negative 16. Okay. And so now we isolate x. So we're going to divide by negative 4. So because this is negative, we're dividing by a negative. This sign is going to change. It's not because the 16 is negative, it's because the 4 is negative. So we have x greater than 4. Okay, to graph that again, our endpoint is an open circle pointing to the right, and the solution set in this case would be 4 to infinity. Solve and graph the solution set. So this is a compound inequality as we talked about previously using the word and. In this case, you work across the inequality, as I like to say. So in order to isolate x in the middle, we need to subtract 4, and we're going to subtract it from each part of the inequality. Okay, so we're going to subtract 4, and subtract 4. Negative 1 minus 4 is negative 5. We keep our inequality the same, x less than 4. Okay, so x is greater than or equal to negative 5 and less than 4. Okay, so our solution set, negative 5 is an endpoint with an or equal to, so it gets a closed circle. 4 is an endpoint with just a less than sign, so it gets an open circle, and our solution set is in between. To write this in interval notation, we start from left to right. So our leftmost endpoint is negative 5, and it has a closed circle or the or equal to part of the inequality, And then we move to 4, which is an open circle. Okay. Thank you for watching. If you have any questions, please feel free to reach out to me.